Hello and welcome to the 20th episode of our Black Hole Battles game development here on Let's Code Physics. That is something big to celebrate. I've never had a series go this long before. I'm very excited about it. Another big thing to celebrate, if you notice, my game is running. That's right. If I go over here and click on the other ship, what you'll see is that I've got the old enemy controls deselected, so that's been deactivated, and I've got the enemy controls based on control theory activated, and she's running pretty well. There's still some fine-tuning to do. We'll talk about a little bit of evaluation at the end of today's video, but she's running, and that's the best you can hope for when you first start out, is to just get the thing running. So what I want to do today is I want to show you how I finished this thing out, finished out the control theory. I also want to come clean and confess a couple of infinite loops that I had set up in my code that you probably noticed and probably railed about on the comments, but I'm recording these videos a few weeks in advance, so sorry I have not been able to incorporate the comments into here. I'll have to make a specific comments response video a little bit later. So first, let me show you what I finished out here. Last time, we set up the cost calculation code up here so that we could evaluate which trajectory was the best trajectory. And the only thing I had left to do was plan the execution of the trajectory. So I've got this I've got this new subroutine called plan execution, or plan exec. What it takes as arguments is the best trajectory, so the trajectory that you've selected. It takes in the position of the ship, so where the ship currently is. It takes in the ship's current velocity, and it takes in the ship's current orientation angle, because those are the things it needs to be concerned about. I'm inputting these as the coordinates, or as the components, and not as vectors. That just seem to be a little bit cleaner. I'm sure you could do it either way. That just seemed to make more sense to me to just pass them individually, since I'll be working with them individually. So here's our plan execution. It's going to return two integers. So it's going to return a list of two integers. The first integer is going to be, I believe, the rotation control. I have it commented here. Yeah, the first one is going to be the rotation control. So that's either going to be a -1 for clockwise rotation, a +1 for counterclockwise rotation, or a 0 for no rotation. And then it'll also have an integer for thrust, and that'll be a +1 for forward thrust, a -1 for backward thrust, or a 0 for no thrust, in case the ship decides that it's best off coasting at that point. And so here we take a look at generating possible control commands. And I debated over how to do this, because the way you're quote-unquote supposed to do this is you're supposed to iterate of points ahead. Basically compare your generated trajectory to the selected trajectory. And you select a control pattern that results in a trajectory that best matches your best trajectory. And I ran into a couple issues with that. Number one, I don't know of an efficient way to loop over all the possible orientations for the controls, because if you think, you've got two variables with 3 values each. So for each point I look at, that's 9 possibilities. So if I look at just one point ahead, I have 9 combinations to consider. If I look at, or commutation or permutation? Permutations to consider, yeah. No? Is that permutation? Tell you what, I'm going to say combination in the generic sense. If I'm using that word incorrectly, please let me know in the comments. If I look ahead 2 points, then it becomes 9 squared, and it's 81. So it's going to go up like 9 to the n, which is a pretty strong, steep, increase that I was not terribly hip on eating up a lot of computer time for. But I was also thinking about it. This is not like a self-driving car. So this control mechanism was inspired by self-driving cars, which I'm still following. I'm still basing my inspiration on that. But a self-driving car can look ahead several steps because it knows what the road looks like. But this ship it presumably is being piloted by a human. It's not a self-driven ship. It's presumably being piloted by a character with flaws and with a slow brain. And they're not going to be able to think that far ahead because of the gravitational force that acts on the ship. So in other words, this trajectory that I would generate, even if I looked 3, 4, 5 points ahead, is not going to be accurate because it's going to be pulled by gravitational forces that the pilot won't necessarily be able to calculate in their head. Now, I do have the look ahead subroutine, and I might incorporate that into this for a harder enemy ship, but that still leaves me with this power law growing of the number of possibilities here. And so I need to do some research, find out an efficient way of doing that. So right now, it probably seems a bit anticlimactic after all that trajectory generation. But right now, the ship is only planning ahead one step. So it's looking over the next step, and basically it's looking for what its next rotation command needs to be, and what its next thrust command needs to be. So it loops over for the rotate command and for the thrust command between -1, 0, and 1. And let's see, yeah, so it calculates what the next angle would be based on how much that would rotate it. And it calculates what the next velocity and position would be based on the thrust, and it occurs. Yeah. I put in the correct angle here. I put in the next angle. I just blanked out for a second, wondering if I'd put in the next angle. So we have our velocity vector being updated, our position vector being updated. I formed those out of the components here, so yeah, I suppose I could have just passed those in, but I don't know. It just feels a little bit cleaner to set up its own vector in here rather than having to worry about accidentally changing the ship's position manually in here. And then basically we add to the list the rotation command and the thrust command, and then it returns that list. So if I go back up here, once it has this plan exec finished, it has that list stored in next step, and it uses that to determine the next rotation. So that's next step element 0, and then it applies the next thrust using next step element 1. And then we are done. We are done with fixed update, and our control theory has been implemented. And as you've seen, it's running. However, it was not always running. When I first finished this, I was very excited, and it froze. Not it tried running, it just plain froze. Like the play button did not even turn blue. And that is a bit of a problem. I couldn't click anything. It became unresponsive. In order to debug this thing, I had to comment out code and then run Unity, and then when it froze, I had to literally exit Unity and come back in. This was after I spent a day reinstalling Unity just to be sure it was all right. And I tell y'all, I was getting ready to plan a video where I had to announce the conclusion of Black Hole Battles because I was afraid that my computer had broken and it would no longer run Unity. Fortunately, that is no longer the case, so we are here for episode 20, and here's to another 20 episodes. But the reason it was stuck is not because my computer was broken, but because I inadvertently put in a couple of infinite loops. The first infinite loop I had was, or actually I guess that's the second one. Well, the first one I have in the main subroutine in fixed update is in this cost calculation. So I had this checking for so I had this search radius expanding, but I had that somewhere embedded in here to where it would just keep expanding and keep expanding. So I changed this to be external to whether it's within this collider loop or not. So that it's not in this collider, or so that it's not in the I think it was it up here or up here? I don't remember. Either way, I moved it out here and it helped. And so now we are checking for whether there's black holes within a maximum search radius, and then we're setting no black holes equal to false so that this thing can exit sooner. The other issue that I ran into, the more significant issue, was down here in make trajectory. Down here I had an infinite loop, and again I probably got yelled at about this in the comments. So I had this calculation for the goal time, right? So it's simple calculation, right? Actually it was up here. Now it's commented out after this so that there's no memory of it except here on YouTube, which is goal distance divided by the magnitude of the velocity, right? That's how you're supposed to calculate time. Except this is a problem when the ship is at rest, right? So if the ship is at rest, like it is at the very beginning of the game, the ship starts out at rest, then this velocity is 0, and you are dividing by 0. And Unity is apparently built by physicists. It's apparently not built by mathematicians, because this calculation returns an infinity. Not an error, not an NaN, not a divide by 0 error. This returns an infinity. And so when I had a loop down here that said, while the point time is less than or equal to goal time, this was while point time is less than or equal to infinity. So this thing was always running. It was making an infinitely long trajectory. And it was so fun to run this thing. Where I finally figured out it was an infinite loop was when I ran this thing and I had my task manager open on my other screen. And the memory taken up kept growing and growing and growing and growing and growing. Even though the CPU, the processor, was fine. It was just, at its, regular speed or whatever. The RAM, the memory, kept growing and growing and growing and growing. And so I've put in a couple of safeguards against that infinite loop, against having to make a trajectory that stretches out infinitely far in time. First of all, the goal time is going to be a minimum of 100 seconds. So is going to be that's going to be a maximum of 100 seconds. Yeah, because if you take the minimum, then this is the highest it's going to be. So I've taken this velocity calculation. It's a perfectly good velocity calculation. Thank you very much. And it's now down here, but we're comparing it against 100 seconds. I might increase that. I don't know. It seems to be working fine right now. The other thing I've done is to, just in case that breaks, or just in case that takes too long, or whatever, I'm also making my my number of points to consider 100. So this thing is only going to loop 100 times, so you're not going to have any more than 100 points in a trajectory, because I think that should be enough. I mean, depending on how far out it goes, I could do a fixed length. That's the word I'm looking for. I could do a fixed arc length like I did with the plot trajectory, but I'll think about that as we continue along. I've also increased the amount that point time changes by. So previously it was changing by the frame time, and that was, again, producing a lot of data points, and they were very, very close together. And what that meant was when I went to do the plan execution. Oh, we never talked about how this actually selects a point. My bad. So what it does is it iterates forward what your next velocity and position is going to be, and it evaluates the difference between where that new position is going to be, so where the actual position will be, and it just selects the orientation, selects the combination of rotation and thrust that minimizes that difference. Okay, so there we go. Now I finished talking about that. Y'all been sitting there saying, no, go back up to that loop. We want to talk about that loop. And so with those being so close together, because of this thing being so small, the plan execution was not really that good. It basically said, oh, I can stay at this point. Oh, I can stay at this point. And so it wasn't doing anything. And so this will also, help the performance, because it won't be running so many times. And so now we're looking 100 frames ahead. Again, that's a factor to play around with, and I'll give that a try, see how it affects the performance. But yeah, she is running pretty well right now. I haven't done much in terms of evaluating the enemy ship's behavior. It's doing a pretty decent job avoiding black holes. It's doing a whole lot of turning. I mean, I guess that makes sense, because it's probably selecting a lot of sharp trajectories or something. So like right now, it's pretty much going in circles, and I think it's about to hit a black hole. Yeah. So I need to come up with some tests to compare this to my previous version, because the previous version was fine. It was a little clunky. This one seems to favor spiraling around. So one of the things I need to do, the thing that's I think it's going to be next on my list. I know I say at the end of these videos what I'm going to do next, and then I show up in the next video and I'm not doing it. I probably need to start writing those things down. But the thing I want to do next, the thing I would like to do next, is to take a look at creating a trajectory display, so showing the trajectory that it has selected, because if it's constantly changing which trajectory it's trying to go on, that might explain the turning. One thing I could do, if that ends up being the case, is have it only select a new trajectory or generate new trajectories, say every 10 frames or every 100 frames or something like that, so that it actually follows a trajectory for a while before it decides to change trajectories. So that's something I'll take a look into, but I think getting the trajectory visualized first would be a good first step. Alright, so that's it for today. Thank you for watching. I hope this has been a helpful I need to be in the game view to move my ship, don't I? I hope this has been a helpful learning experience. I am going to see if I can knock this guy into a black hole, and I hope y'all have watching, and I will see you next time. Bye-bye.